The day of my high school graduation ceremony was the day the Great East Japan earthquake happened. So when I was celebrating with my friends, I experienced this really large shake, and many of the manholes started popping up and a lot of water came up onto the surface. That really got me excited or interested in disaster resilience and how we can make cities more resilient to natural disasters. When I entered college, I saw this video of mobile phone location data plotted on a map and showing how people's mobility got really disrupted because of the earthquake. And that really got me excited in big data analysis, human behavior data that has kind of continued throughout my research. Welcome to my office. I lead the Resilient Urban Networks Lab, or the RUN Lab, where we develop computational tools and big data-driven models and methods to make cities more resilient, sustainable, and equitable. We deal with a wide range of external shocks, like natural disasters, including hurricanes, floods, wildfires, and earthquakes, as well as the pandemic. We've been working a lot on understanding the resilience of economic systems, like businesses, and also we look at positive shocks, how positive shocks could affect urban environments and the broader economy and human behavior. We think of cities as complex systems, which are not just physical infrastructure or networks like the power network or the road network, but also we look at the interaction with the human behavior aspects and the economic networks and implications. In civil engineering, we have looked at urban resilience from a more physical infrastructure point of view. So we've looked at how road networks or physical gray infrastructures, how can we make them resilient to external shocks? But we found that during a pandemic, especially, even though the infrastructure is completely fine, people's behavioral change could have significant impacts, like businesses closing because people stopped going to the offices and they're not going to the restaurants nearby. And so looking at the interaction between the physical environment and the aspects of human behavior is really important in understanding the overall resilience of the urban complex system. So for example, how do people evacuate or react to natural disasters like wildfires? Who evacuates? Where do they evacuate to? If they evacuate, when do they come back? Or do they migrate to another location? Those kind of information we can use large-scale behavior data to analyze those behavioral patterns. So for example, smartphone GPS location data is one major data source that we're using for analysis. We can start to model using machine learning and causal inference techniques how people react to and why people make decisions, where they go, or what they decide to do after a disaster, and use that to start to study how in hypothetical scenarios, hypothetical disaster scenarios, how would people react to that event and how would cities recover. In the context of disaster resilience, we're building agent-based simulation models that can simulate how people react to and how people evacuate after a disaster. So right now, traditionally, we've been looking at building models using big data approaches, but the limitation of that approach was that it's really difficult to simulate human behavior patterns in hypothetical scenarios, which have never happened before, so we have no training data. Right now, with the improvements in large language models or generative AI techniques, we have a better capability of predicting human behavior in very different specific contexts. And so we're developing LLM, large language model based agents, and using generative AI to make better predictions. And this has resulted in a collaboration with an NGO called FlowMinder, who does a lot of humanitarian aid. Earthquake happens in Haiti, they need to be able to understand or predict where would people evacuate to. And based on that information, they would allocate emergency supplies. We have a National Science Foundation funded grant looking at the economic impacts of electric vehicle charging stations. Traditionally, I think, EV charging stations have been placed based on the utility of drivers. But we found using causal inference techniques that placing an EV charging station near a business has significant positive spillover effects. They go to the nearby cafe, they go shopping, or they go to the gym. And you can utilize that social dynamics by cleverly placing EV charging stations so that it helps boost the local economy. Another aspect that is very important is the privacy and the risks of this data. So we've been using a lot of this mobile phone location data, which is hyper privacy sensitive. There has been mainly two areas or two avenues of research that we're pursuing to mitigate this risk. One is to create synthetic mobility data. We're developing approaches to create fake but realistic human mobility trajectories. Another direction that we're looking into is to do the data collection ourselves. we can actually go to the communities and collect the data in a more mutualistic way. So more precisely, how we can help disaster managers or policymakers make cities more resilient to disasters is to provide them information about predictions of where people would go if a disaster happened at this time in this kind of specific way. When I was a master's student back in the University of Tokyo, we developed a model that can simulate how people would evacuate if there's an earthquake. And there was actually a big earthquake in Kumamoto, and we were able to model and simulate and predict which locations would people evacuate to after an earthquake. And based on that information, the government can take that map that we generated and think about where to allocate resources.